building, and who is this project aiming toward? Now let's delve into the basic requirements of our target archery database project. The following requirements have been identified. Store archers information, track scores of archers, store details about rounds and ranges, link archers score to round, competitions and championship, information about divisions, tracking of equivalent rounds.
Our objective was to create a user-friendly database interface that allows archers to easily access and track their scores, simplify administrative tasks for club recorders by streamlining the addition of new archers, rounds and competitions, enable archers to filter and analyze scores for easier progress tracking and performance evaluation. Our mission is to create a database solution for archers and club recorders. We provide easy score access and progress tracking for archers while offering a streamlined system for accurate record keeping to club recorders. With a focus on compatibility, security, and privacy, we aim to enhance score tracking efficiency, enrich the club environment, and enable future development opportunities.
I will explain the implementation of the database briefly. First, we have the archers table, which is the table that stores information about an archer in the club. Moving on, we have the equipment types, which is the table that keeps information about different types of equipment. In this case, there's 5 equipment. And then similar to the equipment types table, we have some tables that can be created through the internal project requirement. So for example, we have target faces for all the size of the target face. We have a distances table for all the available distance. And then we have the first junction table, which is the archer equipment. It basically connects the archer table and the equipment types table. Moving on, we have championship. It keeps information about championship, like name and description. Moving down, we have competitions. The table records data related to individual competition. And a competition can make up a championship, so we have a Boolean value for it. Moving down, we have rounds. The table records information about different rounds that an archer can shoot. We also have ranges, which is basically round details, and one round can have multiple ranges. We have the scores table to record the total score of one round. Moving up, we have range scores, which is the table that records score for each range of a round. And then similarly, we have ends, which is the table that records score for each arrow shot during an end. Then we have divisions for the archers, and we have the archers division table, which is the junction table for archer and division. We also have equivalent rounds, records information about rounds that are equivalent to other rounds from a specific period of time. And then lastly, we have competition rounds. This is also a junction table that links all the rounds that are competition type, because we also have practice type round.
Hello everyone, today we'll be testing our database performance using queries ranging from very simple to quite complex. Now, due to the limitations of macro-root data, you will notice that our data becomes more meaningful the more we enter. There may be minor hitches due to the lack of logic from macro-root. With more time, we could implement a Python script for bulk data entry. But for now, let's see how our database retrieves and performs. First, we will go through some simple queries. Query 1, a query to retrieve all archers. We could write select all from archers. Query 2, a query to retrieve all the equipment type. We could write select all from equipment types. Query 3, a query to retrieve all rounds by writing select all from rounds. Next, we will go through some immediate queries. First query, we would get all the rounds an archer has participated in. Some archers might have multiple rows with the same round to indicate that he or she participated in the same round but maybe on different dates. If we wanted to see unique combinations of archer and rounds, we could simply do accordingly to see the dates of each round participated for the archers. Let's say if the recorder or the archer wants to check the date they participated in, they could write next. Getting the total score of archers, we could write. Note that archers can have multiple rows for the multiple rounds that they participated in, which leads to multiple total scores for rounds. Last, we'll go through some complex queries. Queries to get the average score for each round across all archers. The next query we could try is to get the top 3 archers with the highest score of all rounds. Next, the query to get the number of rounds each archer has participated in and the average score. Finally, to get the archer's personal best, we could write So next off, we're going to show you our main use case using a web application that connects to the database, pulls in data, and allows you to insert the archer's scores. So as you can see, choose a round. You could choose a round from the drop-down menu. You could choose an archer from the drop-down menu. It displays the archer's details by name and the equipment the archer has. You can click the Done button to take you to the score input page, which you could choose the number of ends, which is 5 or 6, and you could enter 6 scores for each end. X equals 10, 10 equals 10, of course 9, 8, 7, 6 equals their respective values. M equals misses, which should be 0. So if you click M, it inputs 0. You could just basically fill in all the scores in each end. Let's fill it up. And once you're done, you could click Submit Score. It takes you to a successful submission score page, which basically shows you details of your arch ID, the round ID, score date, and the total score, which can be validated by looking at the database. As you can see, in the scores table, arch ID, round ID, score date, and total score matches the details that are displayed on the web application.